Welcome back. Now we're going to continue with Newton's laws of motion. Okay, I'm going to do an example and just go through it with me. Okay, the only way to get a hang of these, and trust me, when you've got the hang of it, okay, they're actually very simple. You won't regret spending a bit of time just getting the hang of these. Also, a very, very critical section for next year and the year after. All of these play a significant role, right? And remember, what happened to some of my students recently is that they forgot that the grade 10 work is re-examined in grade 8. So you've got to remember these, they go with it. It's not goodbye Newton's laws of motion. These go right through into grade 12, okay? So let's have a look at the truck. What did we say? We said the truck it was at a red traffic light. So let's just draw at the red traffic light. Here we go. There's the truck. Which means it is at what? It is at rest, correct? If it's at rest, it means that it's standing stationary. Now I'm just drawing it like that. Less time. V equals 0. But which V? Because now we've got defined V's. This is VI, initial, equals 0, right? Then we said that after, now what I do is I take my truck. This is at the next point, okay? Let's say this was A, this is now B. And they say that at point B, okay, what have we got? At the next point, we've got the truck was traveling at 120 kilometers an hour. Therefore, VF is 120 kilometers per hour. All right? What do we do then? Well, we say, right, V final is 120 kilometers per hour. The next step, okay, is to do what? Well, we need to now change that. But now in these, we put down here VI equals 0. VF equals 120 kilometers per hour. Okay, so I can say that's 0 meters per second. This one, we know the conversion is 33.33 meters per second. Okay, we know that conversion. Right, now let's have a look what else they give. They told us that that it accelerated in 1 minute, which is delta t is equal to 60 seconds, right? Right, now, they say calculate acceleration. So therefore, we've got that, the only other one, delta x, we don't know, and acceleration, we don't know. So we look for a formula, okay? Let's look at the formulas, right? Now you should take out your sheet. The one that they've given you for the the final exam that you get, and you'll see they're all on there. You don't have to remember these. I mean, I remember them, but you don't have to. Okay, let's have a look. There's a formula, VF. Let's just look at this. VF equals VI plus AT. Okay, what does that mean? Right? It means the following. It means that final velocity, initial velocity, and t, acceleration, is the unknown. Have a look. We know that, we know that, and we know that. Therefore, we say VF is equal to VI plus AT. We look for the one, it's the same as the electrical. We look for the one that is in effect, has got one unknown, and we solve for it. So what is VF? Is 33.33. VI was 0 is equal to plus A times 60. Therefore, A is equal to 33.33 divided by 60. And once again, you get 0.56 meters per second squared. Please don't forget acceleration is in meters per second squared, right? Why? Well, the reason why is actually quite simple. Let's just take a second to examine it, shall we? We said acceleration is delta V over delta T. That is V final minus V initial over change in time. What is that? It's meters per second, isn't it? 30 minus 10 meters per second gives us 20. So the measurement is in meters per second over seconds, which is meters per second times 1 over second, which gives us meters per second squared. All right? This dimensional analysis is very useful. Okay? It's a very useful trick, used very much at when you get to first year university. But we'll use it a few times when we start to look at some of the problems in higher grades. All right? Let's have a look at that. So therefore, we've now calculated it. Okay? Quite straightforward. Well, let's have a look. Can we calculate the distance? All right? Let's have a look at a formula that's got distance in. Okay? Distance is going to be VF squared. Look at this one. VF squared is equal to VI squared plus 2A delta X, right? What does that mean? That means this. It means that final velocity in this case, okay, the final velocity was 33.33 squared is equal to V initial, which was 0 squared, okay, plus 2 times A. What was A? A we worked out to be 0.56 times delta X, which is going to be equal to what we need. Right? So what is this? Let's have a look. Well, 33.33 squared, we're looking for delta X, right? So delta X is going to be 33.33 squared minus 0 squared. Can you see that's gone to the other side? Divided by 2 times 0.56 must be equal to delta X, which is then going to be equal to, let's have a look here, 33.33 to the X squared is equal to that, okay? Divided by 2 equals divided by 0.56 equals 991.86. (991.86 meters). Okay, that is the delta X. So that's the distance that it was taken during acceleration. All right. Let's move along. Let's say, okay. Let's say we've got a car and it is traveling over here at 80 kilometers per hour. Okay? So we're traveling at 80 kilometers per hour. At a distance away over here of 100 meters, we see a stop street. All right? So 100 meters away, we see a stop street. Right. Now, let us say the car can decelerate at 2 meters per second squared. Okay? This is the maximum. So when I put the brakes on, I can only decelerate at 2 meters per second squared. All right? So the question now that comes into play here is going to be, will I stop? Have I got enough? What? Do I have enough braking distance? Right? Very important question, isn't it? Here we are, we're coming along here. I realize I see the stop street, I start to apply the brakes. But have I got enough time to stop? This is the question we're going to be answering now. Right? So, let's have a look. Well, let's put down, first of all, delta X we know is 100, right? Here we've got, let's put down what we know. All right? V initial equals 80 kilometers per hour, right? That we need to convert to meters per second. How do we do it? Well, we take 80, okay? We say we want to convert kilometers per hour to meters per second. So times 1,000 times 3600. So it's 80 times 1000 divided by 3600. Right? It's 80 times 1000 divided by 3600 is equal to, let's have a look, 22.22 meters per second. Okay? 22.22 meters per second. All right? That's the initial velocity in meters per second. Then we say V final, 0 meters per second. Why? It stopped, right? It stopped. So therefore now, let's have a look. What else do we know? We know delta x is equal to 100 meters per second. Delta t, no, we don't know. And, all right, we've got acceleration is equal to minus 2 meters per second squared. Okay? All right. Well, let's have a look. What can we work out? Well, first of all right, we are given VI, VF, and delta x, okay? So let's have a look. They've given us VI, okay, VF, and delta x, all right? And they're looking, they've given us A as well, all right? So let's say, well, what can we work out? Well, VF is equal to VI plus AT, right? This will give us the time that it takes to stop. All right, let's have a look. V final is 0 is equal to 22.22 plus minus 2 times, why minus 2? Because I am slowing down. So it's a negative acceleration. Therein lies the error. That is why if it's a negative, we put a minus sign. All right? Therefore, okay, we say minus 22.22 is equal to minus 2t. Therefore, t is going to be equal to, and we divide it out, divided by 2, it's going to be equal to 11.11 seconds. All right? So we know delta t at that acceleration. All right? Correct? So in other words, if we are doing and we put the brakes on and we decelerate at the maximum, it's going to take 11 seconds, okay, to stop, right? Now, let's see what else we can work out here. Well, let's see. Decelerate at that, over that distance, we've got a time. That's how long it'll take us, okay? Let's have a look from this one. We've got here delta x, okay? Whoops, sorry. We've got here another one. Let's have a look now, all right, at this. Vf squared, okay, equals Vi squared plus A delta x, okay, 2AX, right? Let us see. Let us now put in this one and this one and this one and see what acceleration is necessary in order for us to stop. Shall we? Well, velocity final is 0 is equal to 22.22 squared plus 2 times minus 2 times delta x, right? We're working out the stopping distance, okay? We're working out the stopping distance, okay, if we decelerating at 2. In other words, we know that we've got a maximum of 100 meters. So let's see, right? That is going to be 22.22 squared divided by 2 times minus 2 equals delta x. So let's have a look. In other words, we're saying that if we are coming along with a velocity of 22.2, we've only got 100 meters to stop. And we can only decelerate at 2. That's a given. So we work out how long does it take us to stop. So we've got 22.22 squared is equal to that. divided by 4 is equal to 123.4 meters. So what's the answer? No. We cannot stop in time. Okay? One of the problems with vehicles, a lot of vehicles have got tremendous acceleration, but they don't have a matching deceleration. It's easy to get the car up to speed, but it's difficult to stop it in time. So that is where the concept of a safe following distance comes from. You've got to have enough time to stop, otherwise you hit the car in front. In this case, if he tries to stop, what's going to happen? He's going to go over the stop street, okay? And he's got no options, no choices, right? So therefore, let's have a look at a different one, all right? Let's take I'll tell you what. Let us take just for example, slightly different, it's a next year problem, but what the heck. We're standing on top of a building 30 meters high, okay? And in our hand over here, all right, we are holding out a ball. And we drop the ball. Okay? What happens? The ball falls to the ground, correct? Right. Now now let's put in, what do we know? This is point A, this is point B. At point A, the ball is got an initial velocity, initial equal to 0. At point B, velocity is equal to V final, right? Now, what is this? This is delta x is equal to 30 meters, isn't it? Right. What next? Well, let's have a look. So we've got VI is 0. VF is equal to, don't know. Delta x equal to 30. Delta t time, don't know. But what do we know? Do we know the acceleration? Yes, we do. What is the acceleration? What is accelerating this ball? What is causing that? What causes it? What is pulling it down? There's a force, the force of gravity. Its gravity is the acceleration. Gravity is equal to G 9.81 meters per second squared, right? G is 9.81 meters per second squared. That is the acceleration due to gravity of this ball. Now you can put in all of these numbers and into Newton's formulas, and you can work out any of the answers you like. Next, I'm going to go into graphs of motion. I'll see you on that side. We'll do a couple more of these problems a bit later, but I'd like to get through graphs of motion in the next session, and then ticker timers.